Okay, well, good afternoon, everyone. I'm Wes Rades, Bay Nature's Executive Director, and I'd like to welcome you to today's Bay Nature Talk with Eric Schroeder about leucism in birds. It's a fascinating and often surprising phenomenon where birds display white feathers in places you just wouldn't expect. If you're meeting us for the first time, Bay Nature is a nonprofit, independent media organization devoted to environmental journalism in the San Francisco Bay Area. We publish Bay Nature magazine and host events like this one to bring our reporting to life. Bay Nature Talks are all about connecting you directly with the people behind the knowledge, scientists, naturalists, and writers, so that you can go deeper into the stories that we cover. Today's talk is based on Eric's recent Bay Nature article, which explores leucistic birds through a birder's lens, from a white-capped sparrow in a backyard to strikingly pale hawks and woodpeckers spotted across the region. As we'll hear today, leucism is quite rare, occurring in roughly 1 in 30,000 birds, and can show up in everything from subtle patches to nearly all white plumage. Before we get started, just a bit of housekeeping. If you experience any technical difficulties during today's talk, don't worry. This webinar is being recorded and we'll send you a link afterwards. And if you have any questions during the talk, please enter them into the chat. We'll get to as many of them as possible after the presentation. We also want to make sure to thank all of you who made a donation to support today's program. Each year, about half of Bay Nature's funding comes from community support, and your generosity makes events like this possible. If you're inspired today, we invite you to donate or become a member at baynature.org. Now, it's my pleasure to introduce our speaker, Eric Schroeder, who I'll bring up here on screen with me. Eric is a lecturer emeritus and former director of study abroad at UC Davis. He continues to lead bird walks, teach classes, and coordinate programs for the Golden Gate Bird Alliance. He's also the author of today's featured story and brings both deep knowledge and a birder's curiosity to this topic. Today, Eric will take us into the world of leucistic birds, what causes this unusual coloration, and what it means for the birds themselves, along with some remarkable examples from the field. Eric, thank you so much for being here with us today. I'm going to mute you here and turn it over to you. Thanks very much.
Hey, thanks a lot, Wes. I like the introduction because you previewed some of my subjects very nicely. So it's a pretty good setup to get me into the talk. Let me see if I can get to the presentation now. How's that looking?
Looks great, Eric.
Okay, good. Then let me get going. Let me begin by telling you how I got interested in the topic. Some years ago, my wife and I noticed a female house sparrow in our backyard that had an odd head. It had white on its head where it shouldn't. And I asked around, and I got the response from people that that was an example of leucism, white feathers where there shouldn't be any. And once people found out I was interested, they started sending me pictures. So, and I'd like to add a disclaimer. Last week at their talk on moths, Alan Fish and Kat Chang said that their disclaimer was that they weren't moth experts. But I know Alan, and he's a bird expert and a scientist. My own background is that I started a pre-med major and lasted a quarter my freshman year. And since then, all of my training and work expertise has been in the humanities. But I did teach journalism. I know a little bit about research. And so I agreed to undertake this particular subject. A note on the photography, all the uncredited photos are mine. All of the great photos are somebody else's. They are credited. And many of them were taken by friends of mine who I thank for their help with my work. Now let's get started. I'm going to divide the talk into three parts. And the first one is going to be a kind of general explanation of color in birds and how color is produced in birds' feathers. And then I'm going to get in to black and white and the science bit of the talk, and in particular, melanin's role. Melanin is the most common pigment in birds and is hugely influential in coloration. And we'll talk a little bit about what it does and when it's working, when it's not working, what happens. And finally, the fun part, what you thought you signed up for, the examples of birds with this peculiar coloration. So what makes birds colorful? Most of the talks that talk about color in birds start with melanin, but I'm going to end with it. So I'm going to actually start with some of the rarer forms of color. And we'll begin by talking about pigment. And pigmentation is color that's caused by chemicals. It's produced in two ways. It's produced by food consumption, or it's just produced internally in the body by enzymes. And I'm going to start with our word of the day, cetacopulvins. Cetacopulvins are enzymes in birds that produce warm colors, reds, oranges, and yellows. They're the rarest pigments we're going to talk about today, and they're found only in parrots. And as I say, they're synthesized internally in the birds. They're not a project of anything the bird eats. And here's a great example of them, red and green macaws. This is taken on a salt lick in Peru. And they're chemical pigments that consist of chains of carbon atoms of varying length. When the chain ends with a particular organic compound, the color that's expressed is red. With another compound, it's yellow. And so as you can see in this picture, these birds obviously got the red compound. And another example are rainbow lorikeets. These are from Queensland in Northern Australia. Notice the extensive orange on their breasts, and I particularly like their little yellow booties. I'll get to the blue heads in a minute. And what isn't quite as apparent in these birds is the green on their backs. But if you look at that central bird, you can see it. And I'll talk about green in a bit too, because it's another odd sort of color. The purpose of these contrasting colors on these birds, because the backs and tail are all green. When you see them from above, you mostly see the green, so they avoid predation that way. But when you see them from the bottom, they're very attractive to other rainbow lorikeets. The next class of pigment we're going to look at is porphyrins, and these are responsible for bright green, magenta, brown, and red in one case. Like cetacopulvins, they are synthesized internally, again, not due to what these birds are eating. And they're notable for fluorescing bright pink or magenta under ultraviolet light. These pigments are found in owls, pigeons, and parrots. And I like these two examples a lot. They're most famously found in these birds, turacos. They're a family of arboreal birds that live in southern Africa, where both these pictures were taken. That bright green in the Neisner luri, I saw that once in person. It looks kind of unreal. And the red on the wing of the purple turaco is caused by a particular porphyrin, tyrosine. It's the only example of red feathers in all the bird world that's not caused by carotenoids, which we're going to get to shortly. So it's a real rarity, that particular shade of red. And I mentioned fluorescing. I'm going to get to this. These are two birds with porphyrin pigmentation that looks pretty normal. They look pretty normal. Certainly the saw-whet owl looks normal. I mean, the puffin, it's got its odd beak, but otherwise it looks normal. But when you look at these birds under UV light, they show really differently. UV light, of course, we can't see it as humans, but birds can see it. It's an end of the spectrum that birds can see. With the owl, these particular owls, their feathers tend to lose the UV properties as these birds age. And it's one way that researchers are able to age them by noting how much fluorescing they have on their wings when they're examined. I love the story on this puffin because its bill was accidentally discovered to have these UV properties by researcher Jamie Denning. He was in his lab working on something else, and he shined a UV light on the body of a puffin he had, and this is what he saw. And it completely changed the nature of his research. He's now working on these puffin bills and trying to figure out if they really do attract other puffins. The obstacle he discovered in his research is that the puffins, you can't shine UV light on these birds. They don't like it. So he's actually had to design special sunglasses for these birds to wear while he's doing his work. This is one of the two major categories of pigments in birds, carotenoids. It's responsible for reds, yellows, and oranges. These pigments are consumed rather than produced within the body. And they're consumed in food birds eat. It includes insects, seeds, berries. All of these things contain carotenoids. They're expressed in all kinds of things we see in our daily lives, like tomatoes, for instance, get their color from carotenoids. There's about a dozen kinds of them, and each of them is responsible for a particular red or yellow. Hue, the shade of color, is determined by a mixture of red and yellow, and of course, red and yellow together can create orange. And although that they oh, that's enough said about them. I don't want to get too scientific in this. It's overwhelming enough as it is, even to me, the non-expert. Here's some examples, though, of these things at work in the red heads of both of these birds. Both these birds are from Colombia, and the red pigment are caused by particular carotenoids that they consume. In the case of the Andean cock of the rock, it's a specialized diet of fruits it eats, and a little bit of structural color in there that I'll talk about in a minute that makes that red look almost fluorescent. I don't know if you've ever seen the videos of the cock of the rock, but if you Google cock of the rock, you're going to see some incredible dancing. These birds put on amazing courtship displays. And this is an example of sexual dimorphism. These are the same two species. These are just the females. So you can see how much duller they look. The red-headed barbet is still colorful, but she's pretty subdued compared to the male. And of course, the cock of the rock is very much subdued. The males need that coloration to attract mates. The females don't want the coloration because when they're on their nests, they don't want to be seen by predators. So the females want to be more camouflaged than the males do. Here's a very subtle example, pictures taken by my friend Bob Lewis of pine grosbeaks, the male with the red head and the female with the yellow. And here's an example of that the mixing of the two types of carotenoids, the two colors of it, the orioles. There are very few birds in North America, actually, that are orange, but the orioles are an exception. And this picture also shows another aspect of color, saturation. Hue, I mentioned, was mixing. Saturation is determined by the density of deposit carotenoids. So this bird is colorful in a couple of ways. And carotenoids, they aren't just in feathers, but if you look at these three species, the toucanet from Colombia, the bill has that bright red in it. The lapwing has yellow both in the bill, but on the wattle on its face. And the yellow-billed stork, a bird I like a lot, has got the red on the legs and the facial skin and also the yellow on the bill. I mentioned earlier that they're a product of diet, and here's a great example, a greater flamingo in southern Africa. And these birds are gray as juveniles, and the legs are gray, the bill is gray, and they've got the gray highlights in the wings. And they live on a diet of these small red crustaceans. And as they eat them, of course, they begin to look like the flamingos we know. My only regret of this particular picture is they were so busy eating that I couldn't get a shot of their bills. I should mention too that these birds in captivity, if they don't have the right diet, they'll bleach out entirely. They'll turn white, and this has happened until zookeepers in a couple places figured out what it was and fixed their diets. Okay, I'm going to skip our major pigment type just for a minute, melanin here, and just touch on briefly on a couple of other factors that make up for color in birds. And I want to talk a little bit about keratin, which is the protein building block responsible for hair and fingernails in humans and feathers in birds. Within the barbs of a bird's feather, tiny air pockets, keratin molecules, and melanin pigments are arranged to reflect light in a way that scatters the blue wavelength and absorbs the rest. So the scattering effect reflects blue light to our eyes, acting as a natural optical illusion. And this arrangement of the feathers and the keratin and the melanin together also can produce iridescent colors, specifically blues, greens, and also that ultraviolet light we saw. This is all by way of saying there are no blue pigments in feathers. The color blue does not exist in birds' feathers. If you take a feather from a scrub jay, for instance, and you grind it up, you'll end up with brown powder that's caused by melanin, which we'll get to. So not having studied physics since high school, I'm not going to say anything further about structural color, but we'll look at some pictures. I love these birds, hyacinth macaws. They're birds of the Amazon basin, and I took these pictures in the Pantanal. It's hard to believe that there's no blue in these feathers, that it's an optical illusion. And it's true, as I said, of all bluebirds. I mean, think about the jays I mentioned, Steller's jays, mountain bluebirds, western bluebirds. They're all optical illusions. Okay, and then finally you can get these combinations, colors. They're created by pigment and structure together. The UV examples were an example of that. That wasn't just the pigmentation, but structure was implicated there too. But green is probably the best example of this. There are thousands of green-colored birds in the world, ranging from parrots. There's, I don't know, over 400 species of parrots, hummingbirds, 350 species, and many, many species of birds. As I mentioned earlier, the females have green or yellowish green, particularly on their backs as part of their camouflage. But getting to green in a bird isn't as simply as just mixing yellow and blue pigments, since, as we just learned, there aren't any blue pigments. So green is made up of a combination of pigment and structural color, and it can happen in a couple of ways. Here's two examples. The green jay, which are found from southern Texas to South America, the vibrant green on this, I love that hue of that bird. It comes from a combination of yellow pigments due to carotenoid consumption and the physical structure, which I mentioned, which produces the blue. The red-crowned Amazon lives at the moment only in a small area of northeast Mexico, but I took this particular picture in Southern California, which has a large population of introduced birds. The color in this bird is due to the tacophyllid pigments that I mentioned earlier, the parrot pigments combined with structural elements with blue. So two types of yellowing agents, both though with structural elements. Okay, next section, melanin. We'll start by looking at how it normally affects a color, and then we'll look at the abnormalities. So melanin is the most common pigment found in birds, and it's nearly universal as a color in animals. It's in our hair, whether we got black, gray, brown, auburn, blonde hair. It's the same pigment as that found in birds. It's likewise responsible for skin color in humans, and it's present in the plumage and skin color of almost every species of bird. Birds synthesize melanin internally by breaking down amino acids, unlike the carotenoids, which, as we've seen, have to be consumed in their diets. So there's two types of melanin, and the first one is eumelanin, which produces the blacks, dark browns, and gray colors. And it's heavier and durable than the other type, and it also provides structural integrity to feathers. The pheomelanin produces the browner colors, ranging actually from bright gold to rich auburn or rust, and finally into yellow-hued colors. And depending on concentration, if it has a high concentration, the colors are brighter. Lower concentrations, they're more muted. Most feathers contain a mixture of both, with the overall color being determined by the ratio. This is a favorite bird of mine. It's the southern ground hornbill, and it gets its dark feathers and its bill and legs from eumelanin pigment. And this is true of all familiar blackbirds, blackbirds themselves, red-winged blackbirds, crows, ravens. So this is a classic example of it. And I mentioned another benefit to this was added strength. You probably have noticed that a lot of birds have black wingtips, certainly most gull species, and waterfowl, including snow geese, American white pelicans, whooping cranes. The eumelanin fills in the keratin structure of feathers, making them more durable against environmental damage caused by wind and sunlight. Melanin-rich feathers are structurally sounder. They allow the birds to remain aerodynamic, and they reduce the need to replace damaged feathers frequently. And here's the other type of melanin, pheomelanin, which is responsible for reddish brown, rufous, rich tan colors. And I like this picture because I think this is phenomelanin at its best, this cinnamon teal. This picture is great, I think, because it shows both types of melanin at work. You can see the eumelanin in the black of the wing and tail feathers and on the tips of the crest, and the pheomelanin in the brown color on the back and the head. Okay, when I discovered an even longer version of this table, I was pretty overwhelmed. So I have an idea of how you must be feeling. Hein van Krauw, who is the color expert that I probably consulted the most. I think I looked at 4 of his papers. This is the most recent one. And he had a much more detailed version of this chart. And it lists 7 color aberrations and describes each one. I'm going to simplify the model so as to not overwhelm you with too much information. And here's my simplification. I'm going to skip one of his rare categories. I'm going to gloss over a couple of others, and then we'll look at a couple others in a little more depth. So melanism first, and this is kind of the opposite of what I want to talk about, because melanism is a condition that's caused by a genetic mutation resulting in an overproduction of melanism. So it can take various forms. True melanism is rare, and it results in jet black birds. And partial melanism is more commonly seen, where like my sparrow with the white on his head, you can have a bird with just a patch of black feathers where there shouldn't be. The skin and beaks might be affected, but the eyes are never affected with this particular mutation. I just got one picture for you. There's a fully melanistic house sparrow. It was taken in India. And now I'm going to switch over to the opposite. And this is one you probably know about. Due to a mutation, albinos lack a particular enzyme which result in the bird's inability to produce melanin anywhere in the body. So not just feathers, but skin, eyes, and bill. And the pink that you sometimes see in these birds, it's actually the blood behind the colorless skin in the eyes. Everybody who's an expert likes to stress there's no such thing as a partial albino. It's like saying sort of pregnant. You either are or you aren't. And it's not as rare as it might seem, but because of because of the absence of melanin in the eyes, this results in really bad eyesight. And so most birds that are born true albino birds die young because they don't see well, and that's their cause of mortality. The mutation doesn't affect carotenoid pigmentation, which we'll get to right now. I'm sorry. Second slide after this. This is just what we think of when we think of albino. There's the picture of a carrion crow, which Ebert likes to call the quintessential big black crow, and the albino version. And you can see complete white feathers, pink bill, pink legs, and the red eye. Here's the one I want to show you. Another albino bird. This is a surprising picture because we think of albinos as completely white, but the red and the yellow in this bird is due to the presence of carotenoid pigments. So the melanin drops out completely, but it's still got carotenoids in it, which is why it shows color. But if you can, I don't know how big your screen at home is, but if you look at the eye carefully, you can see that it's a red eye, and it's caused by a lack of color in the eye. We're looking at the blood behind the eye. I hesitated to include this slide and the next one in here. Maybe if you need to grab a coffee or snack, now's a good time. I'm going to talk a little bit about Van Gross's categories here. He emphasizes there's no such thing as a partial albino, but he uses the more general term albinism to describe a couple of his other categories. And the first one is a brown mutation, and it's a particular kind of alteration that affects melanin production, causing the black pigments to appear brown and reduces the overall intensity of dark colors. He actually claims that this is the most common cause of aberrant white feathers. He says it's the most misidentified hereditary aberration in birds, and I'm quoting him here. It's sometimes almost white, making identification challenging. This is this is the theme for the rest of the talk, trying to separate all these categories. Okay, the Eno mutation is caused by a recessive mutation resulting in a severe reduction or total elimination of melanin in the feathers, eyes, and skin. Pretty similar to the other one. He claims that, quote, any adult wild bird with white plumage and reddish eyes is probably Eno, not albino. And of course, he claims this because these birds have a little bit of melanin in their eyes, and so they have some vision. They're not, their eyesight isn't nearly as compromised as that of an albino bird, so they have a better chance of survival. As you'll see, a lot of what is said about these mutations is also going to apply to leucistic birds. And here's the other term of his I'm going to touch on briefly. It's called progressive graying. And a lot of you're going to see that what he describes here looks a lot like the birds we're going to refer to as leucistic, because they have a lack of melanin in their feathers. But unlike leucism, progressive graying isn't a genetic defect. Genetics may be implicated slightly in there. This is a subject that's still up for a lot of discussion, but the consensus seems to be that the primary cause of progressive graying are environmental factors in these birds. And like leucistic birds, skin and beaks may be affected, but the eyes are never affected with this. And I'll wind up Van Graaf by showing you two pictures from his papers. One, the brown form of albinism, a common gull, and this song thrush, which would normally be a pretty brown-looking bird, are examples of these two aberrations. I didn't include a photo of a bird with progressive graying because I couldn't actually find one in my search. And I think this is because of the fact that it's difficult to identify these birds in the wild because progressive grayism, these birds get grayer with age each time they molt. They start off looking normal when they're little young birds, and then each time they molt, they get grayer and grayer. And so the fact that this occurs over time, I think, makes it difficult to really say that's what you're observing in a particular bird unless you see it year after year come back and it gets grayer and grayer. Okay, let's get on to the fun part, Leucism at last. And when I consulted my mentor and pal, Bob Lewis, after I'd read about a half dozen of those articles on white birds, I was thoroughly overwhelmed. I took solace in his advice. And this is Bob talking to me. From a birder's point of view, mine that is, I can tell if a bird is white and it shouldn't be, if it has some white feathers where it shouldn't, and if it seems paler than it should. And if I can see the eye and bare part of color, and the bare part of the skin, that can be useful. So I'd encourage a birder to note what he sees rather than get embroiled in finer definition points. Thank you, Bob, for this advice. With that in mind, the last part of the talk, let's look at the pictures that were included in my original Bay Nature piece. But first, just quickly describe what leucism is, right? It's a partial or total lack of melanin in the feathers, and it's caused by a genetic mutation taking a wide variety of forms. Van Graaf actually refers to partial leucism as white spotting. He also applies that term to progressive graying, I should add. With some birds, however, the entire plumage is white. The skin, legs, and bill color they can be affected, but the eyes are always dark. This is key, right? This is why the birds you'll see out there are going to mostly be leucistic birds, not albinos. Leucistic birds are sometimes called partial albinos, but we've already seen that term really is meaningless. They're also called piebald, and this is maybe more useful. It's a term used to describe a spotted or a pied creature, one that is black and white. The term comes from pie, a shortened version of magpie, a black and white bird, and bald, meaning white patch, so piebald. As I read about leucism, I came across that statistic that Wes mentioned, the incidence of leucism in wild bird populations, 1 in 30,000. Everybody quotes it, But I finally found it. It came from Cornell Lab of Ornithology's Project Feederwatch, and it does seem to include birds, all birds with misplaced white feathers, so not specifically just leucistic ones. I ran into Alan Fish last night, and he led counts on Hawk Hill in Marin County for many, many years, where among all the thousands of raptors crossing the straits at the Golden Gate Bridge, there were a lot of turkey vultures. He wasn't aware of that statistic from the Cornell lab, but he told me that he had estimated over the years, looking back at accounts, that 1 in 10,000 turkey vultures were leucistic. So I thought it was interesting that his statistic from his observation was not really that far off in statistical terms than Cornell lab. Okay, the acorn woodpeckers. One of the things I really love about Mark Razan's amazing photo is the eyes of the birds. They allow you to eliminate albino as the cause of the white feathers. I should also mention that this bird wasn't the only white woodpecker at the location. Mark figured out last summer that there were as many as 5 of them there. When I checked, finally went in December and looked for myself. I saw 1, but I talked to somebody a couple of weeks ago at the Bay Nature anniversary celebration who had recently seen 4 of them. As a side note, I should mention that when Bay Nature asked me to do the talk, I laughed given my qualifications. I eventually relented. But then they asked me to lead a walk where people might have a chance of seeing leucistic birds. And given the statistic I just cited, I really laughed, much harder this time. But it's likely Bay Nature will offer an expedition in the fall to look for these particular acorn woodpeckers. Stay tuned. Okay, let's start with a reminder. Carotenoids check, melanism not so much. So here's a yellow rump warbler where all of the melanins have dropped out, but the carotenoid color is still there, so it's still showing it's yellow. Mark Razan, who took this picture, sent me a great description of the bird, and I'm quoting him. It's a butterbutt with mayo, or an Audubon warbler piebald with splotches of white and yellow, gray and gray. Seen at Las Colinas Sanitation Ponds in San Rafael. Only photos were taken, and the white warbler still abides. I think he's channeling the dude at the end there. But to unpack the actual birder lingo, the Audubon's warbler is a subspecies of the yellow rumped, and yellow rump warblers are sometimes affectionately referred to as butterbutts because that yellow on the rump, which you can't actually see in this picture, is diagnostic. Here's another everyday example of leucistic birds, white-crowned sparrows. Alan Krakauer sent me photos of a second one of these birds that he photographed about 100 miles away from this one. I'm impressed in this photo. He was able to get 2 birds to sit next to each other, a regular leucistic one. He took the photo at his home in Richmond, and I'm quoting him here. It has returned at least 3 years, possibly 4 or more. The bird was the VIB of our backyard, very important bird, and we particularly loved finding it with the other white-crowned and golden-crowned sparrows. When Alan told me that story, I was reminded of my house sparrow because it returned for several years in a row. Marty Lycan, a photographer who's bald eagle, we'll look at it in a minute. He sent me photos too of white-crowned sparrow that was taken at Shadow Cliffs Regional Park, nowhere near either of Alan's birds. And he added that that particular bird had appeared 3 years in a row. Here's another great photo. Like Alan in the previous photo, this is Mark Razan again. He was able to get 2 of those birds to pose for contrast. I don't know. I guess that's why these guys are great photographers. I wish they'd tell me how to get birds to do this. And another very white bird, Western sandpiper. And Torgel Zessen, the photographer here, managed to get 2 separate birds to assume the same poses. He found the leucistic one last September at the Don Edwards National Wildlife Refuge in the South Bay. Because it was so striking, he did a little research on eBay, and he ended up suspecting it might be the same individual bird that was photographed earlier in Monterey County and then also in Coos Bay, Oregon. These birds get around. This photo just allowed me the opportunity to stick in one of my own pictures because I liked it. I did a piece on northern mockingbirds recently. Uh, and that's a normal one. If any northern mockingbird can be said to be normal, but it was eating the blueberries in my backyard. I really loved Becky Matsubura's picture because that bird was not only eating blackberries, but it was actually sitting in the middle of the buffet table. And a last all-white bird, Anna's hummingbird, showed up at Alan Bade's garden a year ago. And I'm quoting Alan, it doesn't seem to go to our hummingbird feeders. Perhaps it's avoiding the competition and conflict with other birds. It does seem a little more timid and delicate than our normal hummers. It goes away for a few days and shows up again like a ghost. I love the use of the language ghost because it certainly looks a bit like one. Alan got in a correspondence with a famous hummingbird expert, Sherry Williamson, about this bird. And she wrote him a long response, but the relevant bit of it, quoting Sherry, what appears to be a warm gray tint to the bird's remaining plumage pigment is suggestive of one of the less extreme forms of albinism, affecting both the quality and quantity of normal black-gray eumelanin production by the pigment cells. The defective eumelanin is dull ash brown and prone to fading with sun exposure. This bird is a juvenile by the shape of its secondary, so it's likely the plumage will fade to white over the next few months. I think it's getting pretty close to white already, and maybe it's an example of what Van Grau classifies as an Aino bird. Again, you can see these definitions get pretty technical. I should note Mark Lurzon also sent me a picture of a white Anna's hummingbird taken around the same place and the same time and place as Alan's. It could be the same bird. It doesn't have to be the same bird. Okay, and so I got some pictures here of birds that aren't completely white, but are what would be described as white spotting. And I love this picture of Keith Malley. He's an incredible birder who spends a lot of time at Battery Gottfried, overlooking the bluffs of the Pacific Ocean and near the Presidio. It's got the white spotting on the back, but the tail is completely white, which would normally be the same color as the wings. And I just had to stick this in. I was talking to a friend on the phone yesterday, Tom Nemeth, who sent me this photo. He saw this bird a week ago out at near Marshall in Marin County, and sent me a picture of it. The birds are everywhere, so it's hard to believe there's only 1 in 30,000, or as Alan said regarding turkey vultures, 1 in 10,000. More white spotting. Marty Lycan sent me the wonderful shot of the bald eagle, and a lot of people saw this bird. It hung around in the December of 2024 through the spring of 2025, particularly at Val Vista staging area over by Moraga. And the wild turkey photo is mine. Last spring, I heard a group of 4 wild turkeys that were working the median strip of Sacramento Avenue in Berkeley between University Ave and White. One of them was reported to be leucistic, so I went to look for them. I found 3 normal-looking turkeys near University Avenue. And then 3 blocks along, I saw the leucistic bird on its own and took this picture. A week later, those 3 turkeys I'd seen had actually crossed University Boulevard and were in my driveway. The leucistic bird had disappeared and never did reappear. And I should add that last week I was driving on Pinole Valley Road near Briones, and I saw another wild leucistic turkey in the East Bay mudland. I took a picture on my iPhone, but the bird was pretty distant, and even I have some standards regarding photography, so I'm not going to show you that particular image. We're getting close to being done. Let's just call it Leucism. The black phoebe is great. My photographer pal Rick Lewis calls it the perfect irony, a black phoebe that's mostly white. And finally, the American robin. Bob Lewis saw the bird in Berkeley a few years back. I think this is the ultimate case of white spotting because clearly both types of melanin are affected here. The dark browns on the back and the rufous on the chest. Mark Razan sent me a very similar photo, but it's taken at a different place and much different time, so it's unlikely that it was the same bird. And last winter, I saw a couple of similar photos taken in the East Bay that were posted on eBird. There's a lot of peculiar looking robins. I began wondering if the condition might be passed on, how frequently. I wrote to a professor at UC Berkeley who's an expert on color abnormalities. I didn't get a response. I presumed he was probably out birding. I asked Bob what he thought had become of the particular bird he saw, and his response was something probably ate it. My take is that if it did survive, its appearance would ensure it having a hard time getting a date, so that the likelihood of it passing on its distinct wardrobe would be minimal. I think I answered my own question to the researcher regarding whether or not those birds were passing on these genes. Bay Nature thanks you for tuning in, and we'll see if we end up with that walk in the fall to look for that white-headed wonder there. And if there are questions, I can take the, and I think that Wes has been monitoring that.
Indeed. Eric, I want to give you an opportunity to catch your breath, take a sip of water if you'd like. But certainly with our great thanks, thank you for sharing all of that wonderful information. Thank you for accepting the insurmountable challenge that that we put to you and continuing to accept those challenges out in the field as well. We sure do appreciate that.
Hey, Wes, hang on a sec, Wes. Right over your head, I see Leah Keener, who's has just moved on from Bay Nature to Cal Academy, and she's the person to blame for this. So I don't know if I should thank you, Leah, or what, but yes, well done, Leah, and congratulations on the new job.
A very special moment. So like Eric mentioned, we want to invite questions from the audience. There are two great ways to do that. The first is you can drop your question into the chat, and we'll collect them there. Or if you like, you can use the raise hand function through Zoom, which you can find right at the bottom of your screen under that React button. And if you raise your hand, we can call on you there to bring you forward. While we're collecting the questions, I want to start with just a question of my own. Eric, if you can kind of take us back to the very beginning and tell us a little bit more about the story that you opened your Bay Nature piece with. Take us back to that morning when you saw that white-headed girl in your own backyard, that house sparrow that didn't quite match the field guide. Wondering if you can tell us just a little bit more about that moment and how it led you down the path of noticing leucistic birds more broadly.
Well, yeah, thank you, Wes. It's interesting because it wasn't, it was one of those cases where it wasn't really, really unusual, but there was something off about the bird.
Mm.
And I really had to look at it 2 or 3 times. And, my wife really monitors the backyard bird activity very carefully, and she noticed something was off. And we finally said, the head isn't right. We kept saying, well, it's a house sparrow, but the head isn't right. And then I think I've mentioned Bob Lewis a couple of times, who is a wonderful Bay Area birder and photographer. And I consulted him, and he said, it's probably leucistic, white on the head, it's leucistic. And so I started looking at that. And then a few other people I knew. I was on a trip not long after that to the Sierra that was run by the Golden Gate Bird Alliance, a 3-day trip up there, a bird watching trip. And there were a pair of red-tailed hawks. They were in the distance, and Eddie Bartley, who got a scope on them, put it on one of them in particular, and this hawk was all white. And I said, that's not a red-tailed hawk. He goes, oh, it's leucistic. And so that's when I went from seeing how subtle it could be, like the house sparrow, to this bird that looked totally different. It looked nothing like the size and the shape were red-tailed hawk, but the color, it was a white bird. So I got a sense of how extreme it could be.
That's terrific. I appreciate you letting us know a little bit more about the journey that you've been on. I'm going to turn here, and I see a question from David Bastardi. David, it's great to see you on the call this afternoon. I'm going to ask you to unmute here, and if you'd like, come on the mic and ask your question.
Thanks very much. So my question basically is it the case that some leucistic birds are difficult to identify? Because once the color field marks are gone, then there's less to go on? Or is it the case, as in some of your pictures, that because they're hanging out with other normally colored birds, it makes it easy?
Thanks, David. Well, clearly when they do the latter, it's pretty easy because then you've got that, that side-by-side comparison that I remarked that some of these photographers seem to be really good at getting these birds together. But in the case where you see these birds as a one-off, which happens a lot, it can be much trickier because most bird identification is pattern recognition, but that pattern recognition is dependent on a lot of things, size, shape, and color. I took the Master Birder class that Cal Academy offers with the Golden Gate Bird Alliance some years back. And one of my big takeaways from that is we were told the first day that almost all of us were probably over relying on color as a determinant in trying to figure out what birds were. So, they really emphasize you really need to look at shape and size, and behavior is really important with birds too. So yeah, I mean, it can be tricky with birds that aren't standing next to a similar bird of their own species, but some of these birds are pretty distinct. It's pretty easy to tell what they are aside from color. So, but usually it's going to be a constellation of things that help you to identify the bird. It won't, because the color is the confusing thing. So you're going to need some other markers. You're going to need to be pretty clear on its size and its shape. And as I continue to look at birds, I've gotten much more dependent on behavior to help me make identifications, what that bird is up to. Is it terrestrial? Does it live on the ground? Or is it arboreal? Does it never seem to come out of the tree? So those kind of things can help a lot too. I don't know if I've answered you as well as I could, but it can be tricky. Yeah, that's for sure.
Thank you.
One other thing I could add is that Leucism, so I ended up in the last part of the talk, I ended up really using that term more loosely. It's based on the Greek word leukos, meaning white. And so, there's a technical definition for leucism, but, I just ended up applying it to all those birds with weird white feathers, whether they would slot, I mean, in some sense, some of those birds probably belong in that more complicated categorization table I showed you. They're probably one of these other sub things, but I think that loosely they could all be referred to as leucistic, given that broader definition of leucism.
Terrific. I see a question here from Jack and Sandra. Jack and Sandra, or the account name that. Would you like to unmute and ask your question to Eric?
Yes, I was just wondering if this leucism affects mating opportunities.
Well, yeah, that's a great question. And I think I got an echo here, but that's fine. Yeah, because as I mentioned earlier, so leucism it's questionable when it's passed down and when it isn't. It seems to me in the case of those white-headed woodpeckers that it's getting passed down. But the other, the counter argument is, think of what I said about color in birds. And males want to be, brightly colored, or if not brightly colored, they want to be patterned in a way that they're attractive to females. So it's a little bit hard to imagine that that an all-white bird, which was originally more brightly colored, is going to be as attractive to a female as a mate. So, I think that technically those genes can be passed down, but practically speaking, it's less likely that they're going to be. So that's why I really wonder what's up with those woodpeckers, because when I found out it wasn't just one bird, but as many as 5 birds, I was really struck by that. And that's the only reason I agreed that maybe I'll lead a trip there in the fall and try to look for those woodpeckers for Bay Nature. Because, they've been there for a while now. They've been there for a few years. They've been there, I think this will be their 4th year. So something's going on with them.
Wonderful. Tom Dietz, I see you with a question. Would you like to come on, unmute and ask your question to Eric?
Sure. I think Eric partially answered it. I was interested in the genetics and how heritable the genes are or whether they're mosaicism, to some of the underlying foundations of the leucism trait.
And
Yeah.
building off Tom's question, Christina asks, in a complementary sense, are there ever environmental factors that can cause leucism, or is it solely genetic?
Well, as I say, most people think those funny colored birds, some of them are the progressive graying are due to environmental factors. I can give you a great example. Blackbirds in Ukraine, because of the nuclear disaster many years ago, huge incidence of white colored birds there, way higher than it would be in the normal population. And scientists clearly link that to radiation, that these birds were exposed to radiation. So sun bleaching is also another cause of it. So, again, there are certainly environmental factors are implicated in this as well. It's always a question of how much of this is hereditary and how much is environmental. Van Grauw, the guy I kept quoting, talks about with those forms of albinism, those birds can pass the genes down, but then they're going to get bleached on top of that. So both of those conditions apply to those particular birds, and those birds can end up being completely white. They can start off as kind of normal colored or gray, and then after 2 or 3 years, they're they're white. They're white birds.
Yeah, Eric, I wonder if we might kind of step back and use that to talk about kind of the bigger picture. Your story, your comments highlight that leucism can come from both genetic or environmental factors in
Yeah,
varying degrees, everything from diet to pollutants to injury even. How
yeah.
would we be thinking about leucism in the context of environmental change? Is this just a curiosity? Or can it be sometimes a signal of broader issues in the ecosystem?
Well, certainly with that case of the birds in Ukraine, something was
Yeah.
terribly wrong. So, and I'd imagine that the same could be true in other bird populations due to, pollution, for instance. That you're going to get more abnormalities in birds, and this is a typical kind of abnormality that you're likely to get is funny colored feathers. It's probably, oh, I don't know, all abnormalities are going to have problems for birds in their survival. But I was going to say, I don't know if it's how much worse it'd be than other ones, but it's not a good one. I can't give it to what I said about normal reproduction and the way that color in males plays a role. It seems to me white birds are going to be problematic.
Thank you. So we've got a final closing question before we wrap today's presentation. But before we get that, I just wanted to make a final call to the audience. If there are any further questions for Eric out there, now's the time to raise your hand in Zoom or to drop it in the chat. Otherwise, we'll close here momentarily. I'm not seeing any hands go up. So, oh, here we go. Sabine, would you like to unmute and ask your question to Eric?
I was wondering if leucism is less of a drawback in birds that are usually more white, like seagulls and stuff, where it wouldn't be as noticeable.
Well, that's a great question. Yeah, I would think that the problem with something like a gull would be in the eumelin production, which I mentioned, the black tips of those feathers. If those were compromised, that is a problem because the eumelin in those instances are providing strength to those feathers. So it's not just it's not just a question of attraction and something like that. It's a question of integrity. If those feathers are weakened, those birds are going to be diminished, their ability to survive. So yeah, even with white birds that have, because all birds are going to have a degree of eumelanin in them, or melanins in particular, both kinds. So yeah.
Excellent. Okay, Alan, you get the last audience question. Alan Bade, thank you for using the raise hand. Let's see, hold on, we'll just unmute you there.
Oh, yeah, I was muted. Hi, Eric.
Hey, Alan, great. It's great to see you here.
Yeah, thanks so much for this fantastic talk. And I wanted to tell you that to a comment first. I did correspond with two other friends of our families who are hummingbird experts.
Yeah.
they did high-speed photography to understand how how they feed correctly. And they didn't have anything to add to Sherry's. They said Sherry summed
Okay.
it up.
Yeah.
So, but they were very interested in it and said it's pretty unusual. But then, do you think that the trait could be passed on without showing up in a bird? So say
Yeah. I know what you mean.
you know what I mean? Yeah,
I know what you mean.
autosomal recessive
Yeah, I know what you
trait.
mean. And I don't have the scientific background to answer that. I'm sure glad I had that disclaimer out there at the front end. I actually taught a class for a while at UC Davis where I was teaching genetics majors how to write better. And I was doing my best to stay above water in that because I'm not a genetics expert, but I know exactly what you mean, and I would assume that that's possible that they have the gene in there, but it's not being expressed.
Okay, yeah, and then the other thing, I've been on the lookout. I've been monitoring some tricolored blackbird colonies, very large colonies, on behalf of for the tricolored blackbird survey, things like that for UC Davis. And there you might have 5,000 blackbirds
Yeah.
all in one tight thing. And I was hoping that I could send you a picture of of a leucistic blackbird, but no luck. So
No luck. Okay. You had a good sample. You had, you're given your sample size,
yeah,
nice try. Yeah.
yeah.
Good.
Okay.
Well done.
Thanks again.
Great to see you. And thanks for that picture. It's a
Oh
stunner.
yeah.
Yeah.
Happy to
Yep.
contribute.
Yep.
Alrighty, noting that we've reached the top of the hour, I've got just one last question to send us off, Eric. And Lois, I see your hand raised. If you'd like to email in your question afterwards, I'll make sure that it gets over to Eric, and perhaps he can write back. So
Yeah.
Eric,
Happy to.
the last closing question for you is I wonder if you might again zoom out just a bit and balance kind of our perspective on this phenomenon. These birds are just visually striking, but you also note that their coloration can create real challenges for them, from attracting predators to difficulty finding mates. So how do you think about that tension between the wonder that these birds inspire in us and the vulnerabilities that they face out in the wild?
Well, I don't know what to add to what you said because all that's true. One of the points I would add, though, Wes, is that a lot of people I've talked to really dispute that number of 1 in 30,000
Mhm.
and think that it's on the increase. That leucism is really on the increase. That number is it's an undercount. But that could also be a factor of the fact that birding really took off in the pandemic, and not only birding took off, but the technology of birding took off. And so there are so many more pictures of these birds now. And I think it's a factor partly that there's more people out there, and there's more people out there that have equipment and that are sharing these pictures. So I'm going to be really interested to see in the next 10 years if these numbers really keep going up, because I suspect they will.
Mhm.
And I suspect they're going up because as I do think people are seeing more, but I think we'll learn more about why it's happening. I do think there's going to be more environmental factors implicated in the long run.
Wonderful. Well, thank you. Thank you again for sharing so generously your time and your expertise with all of us. To close up, we have a great tradition on these Bay Nature Talks, which is to thank the presenter with a big group thank you and appreciation. So I wonder, we'll give everyone a second here to do it, but if you can turn on your video for a moment, unmute yourself for a moment, and in the count of three, we'll give Eric a big thank you from the group. So unmute yourselves, turn on your videos, and then I see everyone popping on, which is great. Okay, here we go. Count of three. Let's give Eric a big thank you. Okay, 1, 2, 3, go.
Thank
Thank
you.
you. Much appreciated.
Thank you all.
Yeah.
Thank you all very much.
Wonderful
I
talk.
appreciate it.
Thank you so much.
Bye all.
Have a
Thank
great
you.
Wonderful, everybody.
weekend.
We appreciate
Yeah.
you all attending this afternoon. Have a great rest of your day, and we'll
Happy
follow up
May
shortly
Day.
with the recording.
Yeah.